This video is a short tutorial on similar triangles. When you're looking at similar triangles, what we're talking about are two triangles that look very similar but are not the same size. So for example, something like that. These two triangles look similar but are not the same size. And the key is, if they're similar, then their angles are the same. So that means that this angle would have to be the same as that angle, this angle would have to be the same as that angle, and this angle would have to be the same as this angle. And in triangles, it is actually enough to know that two of the angles are the same, because once you know that two of the angles in a triangle, you know the third angle in a triangle. And so all we're looking for when we're trying to work with similar triangles is, do they have the same angles? If two triangles are similar, what we know about them is that their corresponding sides have the same ratio, and we call that the similarity ratio. So for instance, if these two triangles are similar, then their sides would have to be something like this. These lengths are 4, 6, and 8. Well, the smaller one might be 2, 3, and 4. And we know that would be okay for similarity because the corresponding sides, the sides that are around the same angles, 4 to 2, that has a ratio of 2, 6 to 3 has a ratio of 2, and 8 to 4 has a ratio of 2. And we use this fact to solve a lot of problems. You might have a triangle that looks like this. And we're told that they're similar because we have two angles that are the same. And so we want to find out what the missing side is. So for instance, like that. And so what we're going to do is we're going to say 3 over 2 is the ratio of two corresponding sides. And so the ratio of two other corresponding sides has to be the same as that. And so 8 over x. And then you just solve that equation to find out what your missing side is. Oftentimes you'll be given a similarity statement. You'll be given something like this. Triangle ABC is similar to triangle DEF. If that's the case, you can actually reveal the corresponding sides based on where the letters are. So this means that AB corresponds to DE, and BC corresponds to EF, and AC corresponds to DF. And so those three ratios would have to be the same. And so a similarity statement can be very valuable. And sometimes you're asked to actually find a similarity statement, and you have to think through what the correct order of the letters are. And so it's the second one that you have to worry about. The first one, once you set the order, then you just match the second one to that. This last one is a more obscure fact about similar triangles, but it says that the ratio of the areas of similar triangles is equal to the square of the ratio of the sides of the triangles. And so if you have, for instance, in this case up here, if your ratio of sides is something like A to B, so that would be the ratio of sides, then A squared or B squared would be the ratio of the areas. So you just square it, or sometimes you have to take the square root. If you're given the ratio of the areas, you take the square root of that, and that gives you the ratio of the sides. So for instance, if you have a problem where the ratio of the sides is 2 to 3, and that means the ratio of their areas is 4 to 9. And then you need to use those ratios to help you solve the problem.